10 C's, Chapter 1, Measurements. What we have now is the calculations portion of measurements. And the calculations, when we talk calculations and measurement, there's essentially two things we're looking at. We're looking at surface area, which is what we'll start with today, and we're also talking volume. Both surface area and volume deal with three-dimensional solids, whether it's some form of a prism, whatever kind of prism it is that you have. But surface area and volume also deal with pyramids. So if you have a pyramid of some type, we can do surface area and volume calculations for both. So that's what this unit's going to be about. This part of the unit, the calculations part. It's formula-based. Formulas are given to you, so that's a bit of a benefit in terms of the shapes themselves, which we'll review in a minute or so. And there will be some surface area formulas in their entirety given to you, and some you'll have to create. Volume, the basics of volume will be given to you, but you'll have to construct a formula from that. So, lots of little things, not tough calculations, just require some organization and practice. So, if we take a look to start with, let's look at the individual area calculations for two-dimensional shapes, because all the three-dimensional shapes that we have, like this prism, is made up of two-dimensional flat surfaces. This particular prism is made up of a pentagon and then some rectangles, which are two-dimensional flat shapes. So all surface area and volume, even though these are three-dimensional shape calculations, they still require two-dimensional formula to work with. So everything's kind of interrelated. Two-dimensional helps us deal with three-dimensional calculations. So very quickly, going over the shapes you need to be familiar with. First one is circles. Two calculations for a circle. Don't forget that a circle has two key dimensions to it: the diameter, which passes through the middle, or the radius, which is from the middle to the side. Remember that the diameter is twice the radius. When you have a radius twice, you get a diameter. So a radius could also be thought of as half a diameter, because if I have the entire diameter all the way across, well, if I only had half of it, I would have a radius. So they're interconnected. When we want the area of a circle, the amount of space that it covers, it's pi r squared. Pi being 3.14 times the radius squared. Don't forget, it's not radius times 2. If you needed to write it out, it would be pi times radius times another radius, not times 2. But pi r squared is what we want to work with. Last thing with that is we don't focus on using 3.14 for pi. We should be using the pi button on our calculator. The circumference of a circle is the distance around the circle, like the perimeter of it. And that's pi times diameter, or 2 times pi times r. They're the same thing, because how do I get a diameter? Well, that would be the same as 2 radiuses. And we just put the coefficient out front, so pi d is the same as 2 pi r. Either formula works. What's nice, though, is since we use pi r squared, has the radius in it, 2 pi r is often a formula that gets used most often with, because then you're using radius in both cases. From there, we go to a square. Square, all sides are the same. So square is side times itself to get the amount of space that it covers. And since s times s, the s's are the same, side squared is the best formula to use. A rectangle, different abbreviations get used, length and a width. So the area of that rectangle to calculate the amount of space it covers, length times width. But we could also have a rectangle identified as a base and a height, so it would be base times height. Different abbreviations for the same calculation. Parallelogram. Don't see a parallelogram a ton, but a parallelogram, as I've had students describe it in the past, is like a blown over rectangle. So it's a rectangle that has been blown and it's slanted. Parallelogram, opposite sides are always parallel, and it's just a base times height. But we have to be careful with the parallelogram. The base is one of the sides, but the height is the distance between them. The side length is not the height. The height is the distance from base to base. So if this is the base in the second parallelogram I've sketched here, the height would be from the base to the opposite base, not the slant height. There's your height there. So that's the parallelogram. These are shapes you've been working with for years, so it should hopefully not be too complicated. A triangle, doesn't matter how it gets drawn. Base is one of the sides, and the height is from the opposite vertex meeting the base at 90 degrees. So a triangle would be base times height divided by 2 to get half of it. Now, a lot of times you'll see this formula written different ways. Instead of dividing by 2, we can get half of something by multiplying by a half. You might have, instead of base times height divided by 2, 1/2 of the base times height. Means the same thing. I personally, people agree or disagree, instead of 1/2 as a fraction, I find punching in 5/10 to my calculator a little easier, that I'll even sometimes use that formula. All three mean the same thing. You want the base and the height of the triangle, whatever that is, there's the base, and the height is from the opposite vertex meeting at 90 degrees, so base times height in every case, but then we get half of it, whether we divide by 2, multiply by a half, or multiply by 0.5. And the last shape that sometimes we come across is a trapezoid. A trapezoid is a quadrilateral that has one set of parallel sides and two other sides that aren't parallel. Well, the trapezoid formula is a little bit more involved. B1 and B2 are always the parallel sides. So we want to start by adding the length of the base 1 and base 2 together, and we then multiply that by h, the height. Well, height is the distance between bases, so it meets each side at 90 degrees. Distance from base to base is your height. And we finish that by dividing by 2. Again, to get half of something though, I like punching into my calculator. I still go base 1 plus base 2, multiply it by the height, but to get half of it, I like to multiply by 5/10. Both of these, same way of showing, or a different way of showing the exact same thing. Those are formulas you need to be familiar with. You've seen them in the past. They get used a whole bunch. And those are the two-dimension flat shapes and the areas that get used in our surface area and volume calculations. So let's jump into surface area. Surface area, if we take a look at what exactly is surface area, well, surface area is the exposed surface of a solid. That's what surface area is talking about. The exposed surface of a solid. You will often hear me refer to painting the object. If I have any kind of a solid, the surface area would be the amount of surface that would be painted if I were to paint the entire object. So if it's exposed, it would get paint on it. So that's what we're looking at with surface area. Make sure that even though if I were to paint a cylinder, I would be painting this three-dimensional shape, but my units are still going to be squared. We use squared units even though we're dealing with a three-dimensional shape. The reason being it's centimeters squared or feet squared or meters squared is because we're covering the object. It's the flat surfaces that would receive the paint. And so flat surfaces are squared dimensions. So make sure you understand that. Now, the question is, surface area, how do we do it? Surface area itself, really it comes down to the fact that we want the area of each side. Or as they get called, is we call them faces. A cylinder has a round face on top. It would have a round face on the bottom, and it also has this surface, this face that goes around. So you can call it sides, but face is the proper term. So to get surface area, we want the area of each side, and we want to total them, add them up. That's all we're looking to do. So let's walk through a process. You've seen this previously. Some teachers do it a little different. I have a step that I like because it eliminates errors I find. First step when you're calculating surface area for me is to identify the faces that make up the solid. We want the surface area of that rectangular prism. I like to start with an organized step and identify what do we have in that shape. Well, we have a 4 by 10 centimeter rectangle. 4 by 10 centimeters. There it is. Now, not only do I, when I'm identifying, put the dimensions, I also like to identify how many I have. A lot of students will say, oh, this has 4 by 10s. You'll have the one in the front, which means you'll also have that 4 by 10 on the back as well. However, this is why the sketching is important, because every majority of problems I find happen in that first step. Are there really 4 by 10s? Well, like I said, front and back have to be the same, so there's 2. But when we look at the side, we now have a length of 2 and a height of 10. So there aren't 4 by 10s. We only have 2 4 by 10s. 2 of those. And those would be, you could identify as the front and back. What else do we have? Well, we just identified that we have 2 by 10s and 2 of them on the sides. What are we missing? Well, if we're painting the surface area, the exposed surface, this entire object, we would have to paint the top and the bottom, which are also the same. 4 by 2. 4 by 2. And we have 2 of those. So we finish with 4 by 2, 2 of them, which are the top and bottom. This organization step, some students say, I don't need that, but this is where I find over the years 80% of the problems occur. What's great about this organizing is I don't have to now go back to the equation or to the shape each time and, well, what did I use? What face have I already talked about? Once my organizing is done, I don't even need that three-dimensional drawing because everything I need is in my organization step. Now the second step, and this becomes important as you move on in math is I don't want to see 17 little calculations. I want one big single equation to calculate surface area. Surface area, I want it as one equation. Not only does this become efficient and helpful as you move on in math, but it's going to be important in the next lesson when it's not just about surface area, it's about unknowns. So, what makes up the surface area? Before I start jumping in with numbers, I want to just identify what I have. I have two rectangles, and I want to add to that two more rectangles. And I want to add to that two more rectangles. Again, part of the organization. This way, hopefully, I will carefully understand and not forget that I have multiples of each face. I have two rectangles, which are LWs. I have two other rectangles, which will be LWs, and I have two more rectangles, which are LWs. This step here isn't required, but I find it helps eliminate errors. I need to see that equation. This equation helps you eliminate errors. This equation is essential. This shows me you understand what you're dealing with before you start. And now I got rid of the original shape, but who cares? Because I have 2 times length and width. It's all right there in my organization. Oh, it's a 4 by 10 and I have 2 of them. I also have 2 10 by 2s. It's all organized for me. I'm not having to try to figure out which side I've used. My organization step has done that. And I also have 2 4 by 2 rectangles. So that organization step to start with made my substitution step nice and easy. What does that give me? Well, 4 times 10 times 2, 80. 2 times 10 is 20, twice is 40, and 4 by 2 is 8, twice is 16. So we get a surface area of 136 centimeters squared. And there we go with the surface area. The exposed surface, how much space would need to be painted? 136 centimeters squared. Identify the shapes, single equation you can substitute into, and then solve. Here's 2 more. Might want to give it a try, stop the video, see what you come up with, or let's just work together. If you want to stop the video, do it now, and then join us when you're finished. So, identify the faces. Here, if I were painting this pyramid, what do I have? Well, my pyramid is made up of a base, and those little ticks tell me it's a square. And I only have one of them. I would paint the bottom of that. And it's 9 by 9, so I have 1 square. What else do I have? Well, I have triangles that need to be painted. All the triangles have the same base, which is 9. They also all have, for this particular side triangle that we'll focus on first, we see the base is 9, and we have the height of that triangle is 14. So we have a 14.4 by 14.4 meters. How many of those triangles? Well, each of those triangles is a base of 9, and they would all have that height. Now, with a solid, there's 2 heights. This height that we're talking about right now is referred to as the slant height. The slant height is the height of the triangular face. We also have what's called the vertical height, which is how tall the object stands. Slant height will always be a little longer because it has to angle in to meet at the apex. How tall it is the vertical height. We're going to use vertical height later on with volume. Slant height, though, we need the height on the angle of that triangle, which is our base 9, slant height or height of 14.4. And we have 4 of those triangles. So what makes up the surface area? Very quickly, I have 1 square and I have 4 triangles. There's my thinking step. Make sure I know what I'm working with. I have 1 square, s squared, and 4 5/10 base times height. 4, and there's my triangle formula. And I don't need to look at the shape anymore because my organization gives me everything I need. My surface area is a square that's 9 by 9, plus 4 triangles, 5/10 times the base of the triangle I can see easily is 9, and the height of my triangle is 14 and 4/10. So the organization step makes it very easy to substitute the values in. Do the calculation, and when everything gets done, we end up with a surface area of 340 and 2/10 meters squared. Faces, equation, solve. Now this next one looks similar, but it's a little different. Take a look at it, maybe stop the video, give it a try. But what makes this one different before you stop the video? Well, in this case, we don't have a square base. We have a rectangular base, which means our triangles for the sides, we have 2 different dimensions because we have 2 different triangles. We have the 22 by 32 base height triangle, and we have this 26 by 30 triangle. So in our organization, what do we have? We have a 26 by 22 rectangle, one of them, and we have a 22 by 32 triangle, but we have 2 of them across from each other. And we also have a 26 by 30 triangle, and we have 2 of those. So we can identify again all the shapes that make up and need to be painted, what the dimensions are, and how many of each there is. Because that will make my calculation nice and easy. 1 rectangle, 2 triangles, and 2 different triangles. So when I substitute in a formula, I have an LW rectangle, only one of them, so I don't need a number out front, and 2 triangles, along with 2 different triangles, so I need that equation twice. And my nice organization, substitute in, I have a 22 by 26 rectangle, and I have a base height 22 by 32 triangle, and then my last triangle is a 26, whoops, I forgot my 5/10 there, 2 times 5/10 times a 26 by 30 triangle. So this sketching gives me all the information nice and easy. And when I calculate, in this case, my surface area works out to be 2,056 centimeters squared. So with prisms and pyramids, you need to identify your faces so you can create the single equation on your own. Now, what we do have is we have 3 unique shapes that formulas will be given to you. They're unique. They don't get made up of just straightforward the initial 2-dimensional shapes we talked about. So these formulas, you just need to be familiar with them and how they work. A cylinder. A cylinder is 2 circles, top, bottom, and then you have a rectangular. If you unwrapped a cylinder, it would actually create a rectangle. We don't know the dimensions, but those dimensions would be 2 pi RH. So when everything's given to us, surface area of a cylinder, 2 times pi times 15 is the diameter, so the radius would be half of that, 7.5. So 2 pi radius squared plus 2 pi times our h. And the radius we just discovered is 7.5. And the height of the cylinder is 24. So there's our calculation. Now, as I talked about a little earlier, right at the start of this video, pi. We don't use 3.14 anymore. We want to be specific. So if you take a look and you hit second function above that little arrow, you can see the blue pi symbol. It shows up on our display as pi. And if I hit equals, well, there's our 3.14159. So it's more specific than just 3.14. So when we do this calculation, I would want 2 times pi, so I get the pi in there, times the radius, which is 7.5, and we want that squared. There's my first calculation. I have my second calculation, which is 2 times, again, I need the pi, times radius and height. Radius is 7.5 times the height, which is 24, and there's what we get. And I need to combine those two terms. So what I can do with my calculator is I can go up, I hit enter, I want that, and I want to add that to my second part of the calculation, and when I come up with it, I end up to 1 decimal place is always safe, 1,484.4. So we get a surface area of 1,484.4 centimeters squared. From there, same idea for a cone. A cone is made up of a circle base, pi r squared. That would have to be painted. But it's also made up of this curved triangle if I were to unfold a cone. And I can get the area of that using pi rs. It's not a true shape, so we can have the formula given to us. So surface area equals pi times r, which this time we're given the radius is 3, plus pi times r, which is 3, times s, and s in a cone is the slant height. This 9 centimeters is telling us the vertical height, how tall the cone is. But this, on the angle, there's our slant height s. So we would use 11. So pi r squared plus pi rs. Go back to our calculator, practice with the pi. Second function, pi times the radius, which was 3. And we want to square that. So pi r squared. And then we want pi times rs. The radius is 3, and our slant height was 11. Punch that in, and I want to add the 2. So I go up. I want that. I'll hit enter. Plus, go up, grab my second calculation, and that equals 131.9. So we get a surface area of 131.9 centimeters squared for that cone, simply using the formula that's there. Last special shape is a sphere. Because of its roundness, there really are no flat surfaces. The surface area of a sphere is just the formula for pi r squared. So in this case, our 7 inches represents all the way across, and it says it's the diameter, which makes sense. We need to use the radius, which is half the diameter, 3.5 inches. So 4 times pi times 3.5 inches being squared. 4 times pi times 3.5 times 3.5, however you want to work it, that works out to be a surface area of 153.9 inches squared. There's 3 special surface areas where you don't have to identify yourself all the bits and pieces. The formula would be given to you. And the last one that needs to be talked about are composite shapes. Now, composite shapes are shapes when you have multiple solids put together. So we can see with that example, it kind of looks like a barbell, a dumbbell, and it's made up of two, there's one, and there's two cylinders, but we actually have a third cylinder in the middle. Now, with surface area, again, I don't care about the solids that make them up, because surface area is what I would want to paint. Why composite shapes become confusing is we're going to paint, and the identifying faces, that's where these become tricky. Trying to make sure you understand all the different shapes that make up this object. Maybe make it a bit bigger, see if that'll help us a bit. So we just need to paint. Slowly figure out what needs paint. Well, I have this circle here. And there's the circle, and I have it there. I have that circle actually similar to this one. It happens 4 times. It happens on the inside, just like that one, and it happens on the outside again. So there are 4 of those circles that need to be painted. So circle times 4, and we see the diameter is 12, which means the radius would be 6. So 4 circles, radius 6, need to be painted. Well, what else needs paint? Well, this is where you're going to have to think a little bit, because actually the ends here, there, and it'll be on the same thing on the inside of this one, these green circles actually are part of this circle on the inside, but we said we were going to paint that, but we're not painting 4 full circles. Like I've just kind of drawn in, where the inner part of the dumbbell meets that face isn't getting paint. So as much as we have 4 circles here, we have to subtract 2 pieces that are smaller circles, and it says has a diameter of 2.5. So the diameter is 2.5. We want a radius then, because we use radius in our formula. The radius would be 1.25 centimeters. But we need to subtract 2 of those, because these little black dots that I've just drawn in, they're not being painted on the 4 circles we talked about. So, organization here, you have to think. All right, well, what's next? Well, we have these shapes all the way around both of these dumbbells. And what is that? Well, the outside is that rectangle from the cylinder. If I go back to the previous page, a cylinder is the 2 circles and the 2 pi RH, which we identified was that rectangle when you unfold it. So what do we have? If we go back, we have 2 pi RH twice. That's the green part that I've just colored. 2 of those rectangles. And the last piece would be this interior cylinder. I would have to paint that rectangular face again. So it would be another 2 pi RH, but only one of them. And here we can see the height is 6.4 height, and the radius is still 6. But our inside rectangular face, we see the height is 14.8, and our diameter, or our radius, the diameter is 2.5, so the radius is 1.25. Whew! The shape, we see that it's 3 cylinders, but identifying all the bits that need to be painted, That's the tricky part. So what makes up our surface area? Well, we have 4 pi r squareds, 4 circles. But we also have to take away 2 of the smaller circles that aren't being painted on the big circles. What else do we have? We have 2 pi RH rectangles and a last 2 pi RH rectangle. So it's just rectangles and circles, but knowing how many of each is what makes it tough. 4 pi radius we identified as 6 times 6 squared. Subtract 2 pi radius is 1.25 squared plus 2 pi, 2 times 2 pi radius 6 height 6.4 plus 2 pi radius 1.25 and height 14.8. One big long formula. The tricky part is understanding all of the parts. It's this identifying the faces, is what that said before I erased something. That's the tricky part for 3D composite shapes. Understanding all your faces. You end up with 1,041 and 36 centimeters squared. Lots of little steps. So, lots of work in this surface area, but not new. You should have seen this before, whether it was a previous high school course or in your junior high curriculum. We're going to add to this next lesson some different kinds of questions, but get this practice done. In the booklet, pages 37 to 40, omit these sections right now. Don't erase them, don't scribble over them. We're going to have to work on those later. Textbook, page 66, number 25. Great practice with composite shapes. Give them a try, see what you come up with, and have fun with it. See you next time.